Look at the nutrition facts on almost any packaged food, and you will see a specific number telling you exactly how much energy you're about to consume. But that number is a mathematical illusion. It doesn't reflect the actual energy your body absorbs. These standardized labels are calculated using a system that assumes a 100% efficient transfer of energy. It assumes that every single unit of energy inside that package is perfectly extracted and utilized by your biology. Treating a calorie as a fixed, rigid unit of math creates a specific biological blind spot. It assumes that a 100-calorie portion of heavily processed crackers acts exactly the same inside your stomach as 100 calories of raw, fibrous whole grains. This is a scientific calorimeter. Inside this sterile, rigid metallic cylinder, food is literally incinerated to measure its total energy content. But humans are not metal incinerators. We are complex biological organisms with intricate digestive tracts, and running that internal machinery requires massive energy. Because your own digestive system actively consumes energy just to operate, absorbing 100% of the energy in your food is biologically impossible. The number printed on the box is a theoretical maximum, forcing us to reevaluate how we measure the fuel we actually take in. This brings us to a metric called caloric availability. This is the true measure of energy. It is the actual amount of fuel your body successfully extracts from a meal, but only after the physical, mechanical effort of digestion is finished. This side-by-side chart visualizes how this works. A raw stick of celery contains about 6 net calories. But cook that exact same celery into a stew, and your body absorbs closer to 30 calories. The reason for that gap is biological mechanics. Applying intense heat physically breaks down rigid plant fibers and cellular walls before the food ever reaches your mouth. You are effectively outsourcing the stomach's heavy lifting to the stove. We do this with liquids too. Look at this carton of 100% squeezed orange juice. A glass of this juice can contain the exact same sugar content as the whole, solid fruit it came from, creating the illusion that they are biologically equivalent. When you eat a whole, solid orange, your gut has to physically tear through the raw structural fiber. That mechanical process expends systemic energy and actively slows down how fast the sugar enters your system. The juice, however, completely removes that fiber barrier. Drinking it allows the liquid to bypass your body's mechanical toll entirely, dumping the calories straight into your bloodstream with zero physical effort. By boiling our foods, by blending them and juicing them, we bypass the digestive system's natural energy tax. We do the work outside the body, which artificially inflates the net amount of calories we absorb. But physical processing is only half the equation. There is also a chemical cost, known as the thermic effect of food, or TEF. This TEF tax is the exact biological energy required to break down specific macronutrients at the cellular level. Imagine 2 diets that match exactly on paper. They have the identical number of calories and macronutrients, but one is made up of sugary processed treats, and the other consists of whole, complex foods. Your body reacts to those 2 diets differently because of their chemical structures. Simple carbohydrates and dietary fats are relatively easy for your cells to metabolize, but protein is incredibly complex. That complexity comes with a steep metabolic tax. For every 100 calories of protein you consume, your body spends up to 30 calories just to metabolize it. Because of this chemical tax, you only ever net about 70. The chemical complexity of your food directly dictates your net energy gain. A calorie of protein simply does not yield the same biological energy as a calorie of fat or sugar. If the labels on our food don't reflect biological reality, then strict, miserable calorie-counting diets built entirely around those numbers are mathematically flawed from the start. Instead of restricting your total caloric intake, the biological workaround is to prioritize foods with low caloric availability. When you actively choose raw, unrefined whole foods, you reinstate the biological energy tax. You force your digestive tract to mechanically crush and dissolve dense plant fibers, spending your own internal energy to break them down. If you combine those raw, fibrous foods with a high-protein diet, you maximize the thermic effect of food. You compound the total amount of energy your body is forced to spend just to digest a single meal. Sustainable weight management relies on forcing your biological machine to perform the exhausting mechanical and chemical work it evolved to do, rather than starving it based on flawed math. Save this video so you can reference these mechanics the next time you prep your meals.